Hello everyone, welcome back to this channel. In the previous section, we have discussed about how to extract the number from the number plate. But we are receiving a special character while extracting the data. Let's see how to filter these special characters while extracting the data, and also how to read the number plate from the real-time vehicles. So here, this is the output previously we got, and let's see the image also. So this we are converting into gray, and we are giving a solid bilateral filter effect, which helps to extract the data perfect, which is giving a filter to the image to make the image solid, and we are giving threshold, which is ODSU threshold we used, and custom configuration with PSM7. So let's see the image once again. So this is the gray image. After converting into gray, image is like this, and after converting into threshold, we are getting the data. So let's see once this threshold image. Yeah, this is how the threshold image will get, and it will help the OCR to get the data correctly, because we are giving white and black only. We are eliminating the other background. So now let's see how to eliminate this special character from here. So for this, we have to whitelist the numbers and digits, or whatever it is. Number plate generally will have A to Z characters as well as numbers, which is numeric. So let's whitelist that. Let's edit char whitelist. So this whitelist is going to eliminate the characters which is not there in this whitelist. So we are whitelisting only A to Z, which is capital letters, and 0 to 9 numbers. Other than this, it is going to eliminate. So let's see the output over here. You can observe this output. Our number is getting exact. Okay, now let's see how we grab the number plate from the actual vehicle image. Previously we did image extraction using this plate directly. So this plate is straightforward, which is having only number, which is representing number of a vehicle. But here we have a vehicle, and we have other numbers as well as other special characters and logos, and everything is there. So from there we have to extract the number plate. So how we extract the number plate from this actual image is, so we have to find the counters of edges this image. So generally number plate will contain number plate will be arranged with the square box. So we have to find square box, and inside the square box we have to read the characters. So first let's understand and see how we identify this square box using image utils. It means using CV2 and image utils, how we extract that number plate box. Let's see that first. So for that, I'm creating one file which is npr.py. So before extracting, we have to add one more library, which is imutils, and NumPy is already added. I'm importing CV2, import matplotlib, import pytesseract, import NumPy as np, and import imutils. So firstly I want to create one image, show I underscore img. So every time we are creating this image, show. That's why I want to create a generic method, RGB conversion and plot figure, and show. So this will show the image. Okay, first let me extract the image. So this is not played, this is car.jpg, and now first we have to convert to gray. So why we are converting this image to grayscale is, grayscale image is only having minimal colors of the image. So if we go with colored image, it will identify the other special characters and numbers also. So when we convert it to grayscale, it is easy for this compiler to understand the image. So before that, I want to check what is the height and width of this image. Let's print and check what is height and width. 3.13.py. So this is height and this is width of this image. So now let's convert into gray. After converting into gray, let's see the image. Now you can see it is converted to grayscale. Now you observe that this image is little blurry. So let's apply the bilateral filter effect to get that black more visible. So for that, I want to add filter blur effect, bilateral blur effect. So this will show this black numbers and black other elements in the image more visible. Let's first see how it is coming. So you can observe it is better than previous image. So it is representing and showing black more. So now let's convert this image to Canny effect. So I'm giving a Canny effect, this edged and Canny function I'm using and converting this to Canny effect image. So now you can see this image is completely inverted. So background is eliminated and everything is black. Now it is highlighting only the parts which is highlighted more, like this number and borders. Now let's see how we can extract the counters from this blurred image. So for that we have to use find counters method from the CV2. So this method will extract the counters of this image. So from this edged, it means whichever we have applied the Canny effect, from there I am getting the counters. So it means we are going to mask that image with that edged or Canny affected image. So now let's grab the counters from imutils. Let's use this imutils counters, grab counters function and get this counters. And now let's get actual counters. To sort this, we have to use the sorted function and counter CV2 counter area, and this is true. Now I would like to get up to 8 only, and now we have to identify the location of the image. For this we have to identify the perimeter of this image first. For counters and perimeter CV2 arc length. So this arc length function will provide the perimeter of that image, and now approximate value of that perimeter, and if the approx value is 4, this approx value length, if it is 4, then it is a square box. We are identifying the square boxes. so it means it is a square box. So now if it is 4 boxes, we have to find the location and append to this location variable. After that, break it, and then now we have to apply the mask. For applying mask, we have to create array. I'm creating a 0 array with the shape of grayed image. So this grayed image is actual image, but we converted into grayscale. So I'm giving this array will help us to add this mask to that actual image. We have identified the location of this plate. This location need to be added to the mask. So for that, I'm creating an empty array of this grayscale image. Empty array means 0 array. And now image plate, we have to draw the image plate using this mask. So this mask is now, you know what I said, this mask is getting with 0 arrays. We already identified the location of this number plate, so we are passing the counter value of this location, and we are passing the mask. Mask means all empty 0 array will be shaped here, and this getting masked with the image, and we are passing exact location of that image. And 255 is white. So here we are passing the color and the thickness. Now we have to apply the bitwise and function for this image plate to apply this mask. So we are applying this mask to this image. So this is a source of this image, and this is the second source of this image. We are applying destination, which is mask. And now we have to identify y and x values of this array. So when it is white color, so we have converted this to white color when we are converting into grayscale and Canny effect. So when it is getting white color, we are when it is 255, we are grabbing the x and y coordinates of that image, and we have to find the begin x and begin y values of that image using this NP array. Minimum will get the x value, and here NP min of y value will get the begin y. Now here end value and end y. So now we got the x and y coordinates. So let's identify the plate. So I want to identify the plate from the grayed image, which means black and white image, using begin y and end y, which means we are supplying the x and y coordinates, which is begin x and end x. Let's print and see how this plate is getting extracted. Now you can see the plate is extracted perfectly. Now I want to extract this number from this number plate. For that, we have to create a custom config first, and text image to string method, and then let's print this text. I'm commenting this show image function. Yeah, let's comment this print height and width. Let's see only number plate. So now you see the number plate is extracted perfectly using this image processing AZP0909. So it is extracted perfectly. Now I want to draw a bound box for this image. It means I want to draw a bound box here and I want to show the number, this actual number, upon this bounding box. So for that we have to find the length. First we have to get the result. It means we have to get all the image data from this image to data function, and now length, I want to calculate the length of this text, and for I in range n. Now I want to first take the result of this I and strip it, and now if text is not equals to empty, get the values of x and y coordinates. And previously I shown you how to create this rectangle, so here I'm just using the same method, and here I want to show the image. Let's see how this output will come. It will come wrong because we are extracting the result and passing this I and x and y values over here, but from where? Plate. This will get wrong. Why? Because this plate is an independent image, so we cropped this image from the actual image. This is a cropped image, so this, now this x and y coordinates will start from the beginning, so it will become 0 and it will become 0. Now see how this result will come. Now you see, as I said, the image of this bounding boxes came at wrong location. To add this at correct location, we have to give the correct begin x value and begin y value, which is we are grabbing from this NPRA. Here it is begin x and here it is begin y. Now it will come correctly. Now you see the value which we have given begin x and begin y is exactly perfect, and the bounding box is now arranged correctly and number is also coming correctly, AZP0909. So this is how we extract the number from the number plate. So I'm just recapping what I did here. So first I took the actual image and I just checked height and width of this image, and here I'm converting it to grayscale, and here I'm giving the blur effect to get the image more visible, and here I'm giving a Canny effect, which is inversion of that image, and here I'm finding the counters of this inverted image, and here I'm getting the counters from imutils, which we grabbed counters from this find counters method, and this is the actual counters which we sorted exactly. It means we are sorting in ascending order, we are sorting in descending order actually, so it is getting reversed, and we are finding the location of this number plate inside this actual image. So we are getting the perimeter of that counter, and we are getting approximate value of that perimeter, and we are, when it is 4, it means approximate value. When it is 4 means it is a it is shaped as a square box and it is a number plate. We are assuming like that, and we are storing in the location, and after getting the location we are masking the location. After masking the location, we are storing in image plate variable, and we are applying draw counters method and draw bitwise and method, and here we are finding x and y coordinates, and after finding x and y coordinate from the gray image, we are extracting x and y coordinates. It means it is cropping the image. So after cropping, we are extracting the data using our page segment mode, and this is local test data, and this we are whitelisting the values to get the exact number, and I'm just printing the value, and after this I'm reading the result of this data, image data, and from this image data I want to draw the bounding box. So this is how we draw the bounding box. After that I'm showing this actual image after drawing that rectangle. So this is how we extract the number from number plate.